Day 1, Basic Calculator. Let's start with the basic calculator using Python. This project will involve implementing a simple command line calculator that can perform basic arithmetic operations such as addition, subtraction, multiplication, and division. To start the implementation, first I have created a file called as day1.py in a folder called as online training. The first step is to write a function in Python function to add two numbers. So that's the first step. We have to do the same thing for subtraction, multiplication, and divide. So let's start writing functions in Python. Now, functions in Python start with def, with definition of a function and the name of the function. Again, what parameters or arguments does it take? It takes two arguments, x, comma, y. And then this is the start of the function. So what happens is whenever you call an add function, you have to pass two parameters or arguments which are numbers, let's say 2 and 3. And then what will it return? The response from this function is addition of x plus 5. Simple as that. Similarly, for subtraction, and I return x minus y. Now similarly for multiplication, and you return x times y. And finally for division, we have to check in this case what if the value of y is 0, because division by 0 is not allowed. If y equal to 0, then I will say return error division by 0 not allowed, else. So this is a good example of if else loop where it will check if the value of y is 0. If it's not 0, then it's going to go inside this loop which will return x divided by y as the value. So that takes care of all our basic arithmetic operations that a calculator might support in our case. So let's go ahead and define the calculator function. And this one doesn't take any parameters, so that's why empty brackets. Now I want to have it as a command line implementation where it will display some information to the user. So I'm going to say print select operation. So I'm giving an option for my user to select an operation. I'm going to go ahead and put some spaces so it shows up all the way to the top. And then I'll say print first option is add. Copy that 4 times and you know what they are. So second option is subtract. The third option is multiply. And the fourth option I'll provide divide. Now I will write a loop which constantly goes and checks for users options what he has selected. So I'm going to say while true, I want to do this. So when you say while true, it will run in an infinite loop and give these options to user. So first step is I'm going to say let's take input from the user. So what this will do is on the command line, it will stop at this particular function or line of code and ask user enter choices which can be 1 or 2 or 3 or 4. Next, once I give this present this option to the user, I'll wait for the user's input. So just by saying input here on this particular line, on line number 29, what I'm doing is I'm giving an option to the user, and I'm stopping the entire program for receiving input from user. Next, I will check if the input is one of the four options, because what if user entered something else? So I am going to say if choice in, if the user's choice that they entered is one of these options, then what I will do is I will say number one. So that means I need the first number input from the user. So that might be in the float option, it might be a decimal point. So that's why I am asking whatever user entered, let's ask him to enter the first number. So whatever user has selected based on the four choices, addition, subtraction, multiplication, division, I am asking, since it's one of the options that you have selected, what is the number that you want to provide as the first number? So that's my first number. Similarly, once that is done, I will ask the user, what is your second number? So if you want to do, let's say, addition, what is your first number for addition and what is your second number for addition? So once that is done, once I've selected those options, let's move it again a little bit to the top. I will ask user, I will check what user have selected. For example, if the user had selected 1 as their choice, which means user has selected addition, then I will print f, and here I'll say number 1 plus, so whatever user provided as number 1 and whatever user provided as number 2, I want to call the add function that we wrote earlier above and provide that number 1 and number 2 as options. So what this will do is this will take users input as first number and second number and call the add function in here, and whatever the answer is. So for example, I entered the first number choice as 1 and number 2 choice as 2. So then it will pass that 1 and 2 to this function, and I'll get the answer 3 in here, which will be displayed in this print statement. I'll say 1 plus 2 equal to whatever the output of this is, which is 3 in this case. So that's what we will see. So I am going to do this a bunch of times. The next one is for subtraction. Next one, 3, is for multiplication. And the option number 4 is division. Once the value is printed out here, depending on whatever the user selected and whatever numbers he provided, it will go back into the while loop. So I want to give an option for the user to exit out of that loop. So I am going to say here option to exit the loop, and here I will say next calculation. I'm creating a variable and I am asking the user, do you want to perform another calculation, question mark, and I'll ask either enter yes or no. So this will be presented to the user in the command prompt. So next I will check if the next calculation dot lower. So I'm converting whatever user has entered into lowercase, and I'm checking if that is not equal to yes, which means user has entered no or maybe something else. So in that case, I need to get out of this loop, which is the while loop, and get out of that complete function. So I can say print exiting calculator, goodbye. And of course this will be outside the loop right here, and then I will here call the calculator function. So the way it works is, since all these are functions here, none of them will be called in the start. So the first line of code that will be executed is here. It will say calculator. It will call this function. It will go in here and call this function. It will then print these to you and on the command prompt, and then run a while loop constantly until the user says, oh, my next calculation, I don't want to perform another calculation, I want to say no. So it will break out and come out and print this, or else it will keep on running this while loop and keep on asking you what is the next choice that you want. So let's run this and see how it looks like. So I'm going to open terminal, increase the size so it's visible, go to my online training which is on my desktop, and I'll see that I have day1.py. I'm going to clear it out and let's run this day1.py here. The way I run it is I say Python day1.py. It's asking me the questions. Do you want to add, subtract, multiply, divide? If I say 1, let's enter your first number, I'll say 56. Enter your second number, I'll say 28. And 56 plus 28 is equal to 84. It shows me in decimal dot 0 point as a float number because I was taking the input as float, just in case I want to support both whole numbers as well as float numbers. Now it's asking me, do you want to perform another operation? I'll say yes. This time I want to do subtraction. I'll say 20 minus 10, which is 10. Perfect. Yes, another operation. This time multiplication. Say 10 times 5 is 50. Perfect. Another operation. Yes. And this time I'll say I want to do division. First number 10. I want to divide by 0. And it says division by 0 not allowed because we had checked here if the user enters y as 0, the second variable as 0. I want to say error, division by 0 not allowed. Let's say yes again and let's try another division operation. I'll say 55 divide by 5, that says 11. 5 times 11 is 55. That's why it's perfect. But if I say no here, it's going to say exiting calculator, goodbye, and now I'm out of the entire function and also the code. And clear it out. I can run it again. 3, 10, 3. Nope. Out of the calculator function. And this is our day one, where what we did was we built a calculator function or a basic calculator where the calculator prompts the user to select one of the 4 operations: add, subtract, multiply, or divide. The user then inputs 2 numbers. The calculator performs the chosen operation and displays the result. And the user is asked if they want to perform another calculation. If not, the program exits. You can test the program by running it in your Python environment and let me know if you have any problems or issues in the comments, and I'll get back to you. Our day 2 is image classifier using Keras and TensorFlow. Now this project involves building a simple image classifier to recognize handwritten digits using the MNIST dataset, which is a dataset of 28 by 28 grayscale images of handwritten digits from 0 to 9. Here are the steps to implement an image classifier using Keras and TensorFlow. First step is to install required libraries. Here we will install Keras and TensorFlow using pip, and I'm going to go over those steps in a little while. Next step is to load the MNIST dataset. Keras comes with built-in datasets including MNIST, making it very easy to load the data. Next step, we will pre-process the data. The data needs to be normalized to improve the model's performance. Step 4 is to build the model. We'll use a simple feed-forward neural network which is fully connected layers for classification. Next step, we'll train the model. We'll train the model on the training set and validate it on the test set. And finally, we'll evaluate and make predictions. After training, we can evaluate the model and make predictions. So let's get started. So I've already created a day2.python file, and our first step is to import necessary libraries. First, import numpy as np. NumPy is a library for numerical operations in Python. Next, TensorFlow as TF. The TensorFlow is a deep learning library. Here we use it to build and train the CNN. Next, I'll say from TensorFlow.keras import datasets, layers, and models. Now, TensorFlow.keras is Keras, which is included with TensorFlow, simplifies the neural network creation. We are importing datasets, which are the module for loading popular datasets, including MNIST. We have layers, which is used to add layers to our CNN. And we have models, which used to define and compile a neural network model. And finally, TensorFlow.keras.utils import to categorical. Now, to categorical converts labels to one hot encoded format, which is necessary for classification tasks. So now that we have all our libraries imported, our next step is to load the MNIST dataset. Now, to load the MNIST dataset, what we do is we say dataset dot mnist dot load underscore data. Now this, when we call this function, it will give us two different tuples which will have train images and train labels and test images and test labels. Now train images are the training data and corresponding labels which are digits 0 to 9. So for that I will say train images, I want to save in this variable, and train labels I want to save in this data set. This is the first data tuple that we get from this thing. The second tuple that we get is, as I mentioned, is test images and test labels. Now these are the testing data and labels for evaluating model accuracy. So that takes care of loading the MNIST dataset. Now next thing that we need to do is pre-processing or normalize the pixel values to be between 0 and 1. So what here normalization means, we divide each pixel value by 255 to scale the values between 0 and 1, making the training faster and more stable. So for that I will go ahead and say train underscore images equal to train underscore images divide by 255.0, and I'm going to do the same thing for test images. There you go, that takes care of normalization. Now next step is to reshape the images. So I'm going to say reshape the images to 28 comma 28 comma 1 dimension as they are grayscale. So the CNN expects each image in 3D shape, which is height, width, and channels. Since MNIST images are grayscale, each has only one channel, and that's why 28, 28, 1, which represents height, width, and one color channel. So for that, I'll say train underscore images equal to train underscore images dot, call the function reshape, and say train underscore images dot shape 0 comma 28 comma 28 comma 1. Same thing I'll do with test images dot reshape test images dot shape 0 28, 28, 1. So perfect. That will reshape the images to 28. Height is 28, width is 28, and one color channel. Next thing that I want to do is convert the labels to one hot encoded format. Now I can do this using the two categorical that we have imported, which converts labels example 3 to one hot vectors example 0, 0, 0, 1, 0, 0, 0, 0, 0 for classifying 0 to 9. Now the purpose of this is this format is required for multi-class classification with categorical cross entropy loss. For that, what I'll do is I'll start with train images equal to categorical and pass it the train, sorry, not images, train labels. And same thing for test labels. So that takes care of that. Next, we can build the CNN model. Now you can build the CNN model by saying model equal to models dot sequential. So model dot sequential initializes a sequential model which allows layers to be stacked linearly. Our next step, let's move it all the way to the top. Our next step is to build the first convolution layer. I'm going to say first convolutional layer. For that, I'll say model dot add layers dot convolutional 2D. That's the function, and to that I'll pass 32 comma 3 comma 3 comma activation equal to ReLU, and I'll explain this in a minute, and input underscore shape equal to, you already know what this is, 28, 28 by 1. Here all of them are closed. So here what we are doing is we are calling this con 2D 32 3 3 activation, which adds a 2D convolutional layer where 32 is the number of filters to apply, 3 by 3 is size of each filters, which is 3 by 3 pixels, and activation equal to ReLU is the activation function applied to each pixel, setting negative values to 0. And then finally input shape 28 28 1, which specifies the input dimension for the first layer. Next step that we'll do here is I'll say model dot add layers dot max pooling 2D, and inside that I'll say 2 comma 2. So what I'm doing here is it reduces the dimensions of the output by taking the maximum value in each 2 by 2 block, which decreases computational load and helps detect important features. So that's what we are doing here. So this creates our first convolutional layer. Now to do the second convolutional layer, I am going to say model dot add layers dot conv 2D, pass it 64 comma same 3 by 3 comma activation equal to ReLU, and model dot add layers dot max pooling 2D 2 comma 2. So in the second convolutional layer, first we call that con 2D function, which adds another convolutional layer with 64 filters, and the max pooling 2D reduces the output dimension by taking the maximum value in each 2 by 2 block. Now let's go ahead and add one more layer, which is the third convolutional layer. For that I'll say model dot add layers dot con 2d 64 comma 3 comma 3 activation equal to ReLU. So this one adds another convolution layer with 64 filters. No pooling is applied after this layer, allowing it to like preserve the spatial dimensions for flattening, which means we have to flatten. So I'm going to say flatten the 3D output that we got to 1D and add a dense layer. Now for this we are going to use the flatten function, which is model.add layers dot flatten. So this will flatten. Next I'll say model.add layers dot dense 64 comma activation equal to ReLU. Move it all the way to the top. Now what we have done here is the flatten, which converts the 3D output of the previous layer to a 1D vector, enabling it to connect to fully connected dense layers. Now next step is to add a dense layer. So this will be, let's call it output layer with, let's add 10 neurons for 10 digit classes 0 to 9. So this output layer we will be calling, let's write the code first, model.add layers dot dense 10 comma activation equal to, I'll use softmax this time. So what this does is this will create the final layer with 10 units for each digit, which is 0 to 9. That's why I've used the number 10. And then I'm using softmax, which converts the output to probabilities, helping the model classify each digit. So next step is to compile the model. I'll say model dot compile optimizer equal to Adam, loss equal to categorical underscore cross entropy, and metrics equal to, which ones are we interested in? Let's just do accuracy. So here what I'm doing is I am specifying the Adam optimizer for adaptive learning. Then for loss I'm saying categorical spelling should be right, and cross entropy, which helps loss function for multi-class classification with one hot encoded labels. That's what we have. And metrics equal to accuracy, which tracks the model accuracy during training and testing. So next step is to train the model. So I'll say train the model. Model dot fit into our data set, which is train dot images. We have train dot labels for it to know. Epochs equal to 5, batch size equal to 64, and validation data equal to, which is our test underscore images, and labels are in test underscore labels. Perfect. So what we have done is in this function, fit function, which trains the model on training data, we have passed the training images and training labels, which are the training inputs and outputs that we created. Epochs equal to 5. Now this is the number of training epochs, meaning the model will see the entire training data set 5 times. Next, batch size equal to 64. Number of samples processed before updating any model parameters. And finally, the validation data which it can validate against, we have passed the test images and test labels, which is our validation data used to evaluate model performance during the training process. Now, next step is to evaluate the model on the test data. So I will say evaluate the model on test data. So I will call the model.evaluate function, and this function evaluates model performance on test data, returning loss and accuracy. So I am going to say in this particular case test images and test labels, and this will give me back a tuple of test underscore loss and test underscore accuracy. So that's what this will return back. Let's go ahead and print it out just to check it out. F test accuracy, I can just say test underscore ACC, which I've created the variable above, times 100. So it can show me in percentage 0.2 F, and I'll say percent. So it will show me the accuracy of this particular model. Next, let's make predictions on the test images. So I can just say make predictions on test images. I'll say predictions as the variable, and I'll call model dot predict and pass it the test images, and I'll say print f prediction for first test image np dot argmax print, or sorry, I'll take the predictions and display the first prediction. So the predict test images function here uses the trained model to predict class probabilities for each test image, and the np.argmax finds the index with the highest probability in the first prediction, which corresponds to the predicted digit. Now, if I want to see this data in real time and see the image of which it predicted, I am going to import another library called as matplotlib dot pyplot as plt, and then use this to plot the image. Plot dot imShow is the function. Now, which one do I want to see? I want to see the test images at location 0, reshape that to 28 by 28 pixel, and then cmap equal to grayscale. So that's what I'll specify here. Now I'll also give it a title, and this title will be my predicted value, which is, I can say, predicted label is, I will get that predictions at element 0 dot argmax. I can just use that here as a function, and then I'll say plot dot show. So this will show me the function. So now to run it, first of all, I need to make sure that I'm in the right path, which is right online training. I opened the terminal, and I had to, if you remember, install Keras, TensorFlow and Keras. So I am going to say pip install TensorFlow and Keras. It's going to take some time, so I'll wait for it, and once it's done, I'll clear it out and then run this code. Say python day2.py. Run it. It says, oh, it looks like I'm missing a comma here. So that is right over here. I'll clear it again and run it again. It looks like I have still spelled it wrong. So I am going to go here and categorical. So let's clear it out, run it again. And it's going to take some time because it's going to go through all those 5 epochs that we have mentioned, and it has a big data set of images. So I'm going to pause it here and come back to it. And as you can see, it displayed me my plot, which says predicted label is 7, and as you can see the image, it's 7, and I see all the flow through it. If I want to go and clear it out and try another one, so for example, I can go here and I can say I want to see the fourth element. Fourth element, test image is 4. I guess that's a make predictions. Make predictions on test image, predictions, test predict, and I am displaying the fourth one. I'm taking the fourth one. Perfect. So let's run it one more time. And again, it went through the entire thing 5 times and it's going to display me predicted label 4 and shows me the image that it plotted, which is 4. Perfect. So that concludes our day 2 where we did image classifier using Keras and TensorFlow. If you had any issues while following along this particular tutorial, let me know in the comments and I'll get back to you. Day 3, simple chatbot using predefined responses. Now let's build a simple chatbot in Python that responds with predefined answers based on keywords in user input. This will be a rule-based chatbot where we define a set of responses for specific patterns or keywords. Let's start building. So first, let's make a new file. I'll call it day3.py. Now first, I will import the regular expression module to handle pattern matching. So I'll call it import the regular expression module to handle pattern matching, and that is import re, which is built in Python. Next, let's create a dictionary that maps keywords to predefined responses. So I already have it ready, so I'm going to paste it here. So I have this responses dictionary which says hello. If anybody says hello, the response should be hi there, how can I assist you today? Hi. Hello, how can I help you? How are you? I am just a bot, but I am doing great. How about you? So these are my predefined responses where if a user asks for says something, we have a reply for that. Next, let's write a function to find the appropriate response based on the user's input. So I'll say function to find the appropriate response based on the user's input. Now this I'll say define chatbot underscore response based on, let's say, user input. So that's the argument that is passed. Now first step here, I would probably have to convert user input to lowercase to make matching case insensitive. So that I can say by saying user input equal to user input dot lower. Next, I'll have to iterate through the predefined keywords and check if any keyword is in the user's input. For example, I can say for keyword in responses, I want to use the regular expression to search for the keyword in the user's input. I'll say if re, this is how you can use the regular expression, search, and you pass the keyword and search for user inside user input. And if it does, I'll say return responses and inside that keyword. So that's, now what if there is no keyword matches? I will return responses, and if you see, I have something called as default available. So that's what I will return back, which is I am not sure I understand. Could you please rephrase? Next thing, let's move it up so we have enough space to work with. Now next thing is I will write the main function to run the chatbot here. So I'll say define chatbot here inside this I'll say print. So first I'll give a print prompt, chatbot, hello, I'm here to assist you, and I'll ask the user to type by to exit, so I can have a loop running constantly listening to users, which is here. While true, get user input first, where I'll say user input equal to input. I'll specify you so we can prompt user to write something. Now next I'll check if user types by, I have to exit the loop, right? So here I will check if user input dot lower. So even if he types, if the user types by in small or caps, I'll convert both of them to small, and I'll say print chatbot goodbye, and I'll say have a great day, something like that. Okay, perfect. Now I'll break out of that. Next, let's say if chatbot's response based, or not if, let's get chatbot's response based on user input. So in this case what I'll do is I'll say response equal to chatbot response, the function that I wrote, and I'll pass the user input to it, which we wrote here. So I'll pass the user input here and I'll try to get the response from the chatbot. So this, once I have it, I can print chatbot's response here by saying print f. What does chatbot say? Inside here, response, whatever response I get, and that's about it. Now let's run the chatbot from the outside loop. I can just say chatbot, and that's about it. I can get rid of additional lines, but I can leave it as it is. So there you go. So that save your file, and that kind of saves my file. Now I'll open terminal. I can see which folder I'm in. I'm in the right folder, and I can clear it out and run python day3.py. Says chatbot, hello, I am here to assist you. Now my first will be, let's say hello. Looks like I have an error here where it says keyword is not defined. So looks like right here it's keyword, not keyword. So let's clear it out. Let's try one more time. I'll say hello. Say hi there, how can I assist you? So this is based on the first one. That's why it said that. I can say hi. I'll say hello, how can I help you? And similarly I can say help, sure, I'm here to help you. So this way you can add a lot of other responses in your chatbot. So this was the manual chatbot that we used to build. In future, one of these days, we'll also build an automated chatbot. But what we have built here is a chatbot that waits for the user to type a message. It looks for a keyword in the user's input and responds with predefined answers. And the chatbot will continue the conversation until the user types by, at which point it exits. So if you have any questions or had problems with this chatbot, let me know and I'll get back to you. Thank you. Day 4. Spam email detector using Scikit-Learn. Today, we will be building a machine learning model that classifies email as spam or not spam based on their text context. By using techniques like text pre-processing, logistic regression, we will learn to transform raw email data into features that the model can interpret. The project demonstrates fundamental steps in text classification and equips you with the knowledge to build models that processes and interprets text data. So our first step is to get the data. For that, we will go to Kaggle. So you can go to kaggle.com, and if you don't have an account, please create one account. And I am going to say spam base UC Irvine. That's the data set I need. And the first one that comes up, I'll download that. I can download zip, and I will take that from my downloads folder, open it, and I have my spambase.csv file. I will take that and put it in my, let's open this and move it to my or open folder, and inside that I'll move this. I'll call it spam.csv for now. Can close this, don't save, and here create a new file, save it as day4.py. So our first step is to import the libraries. So first let me type them out. Now let's go through each and every line. So first line is import pandas as PD, where we are importing pandas as which is a data manipulation library, allowing you to load and manipulate data in a structured format like a data frame. Then we are doing from sklearn.model selection import train test split, which imports the train test split function from Scikit-Learn, which splits data into training and testing sets. Next, we are saying from sklearn.linear model import logistic regression, which imports the logistic regression model from Scikit-Learn. Logistic regression is used for binary classification problems, in which in our case is spam versus not spam. Next, we are saying from sklearn.metrics import confusion metrics, accuracy score, precision score, recall score, and F1 score. Now, this imports performance metrics to evaluate the model's performance. The confusion matrix generates a matrix that shows the performance of the classification. Then we have the accuracy score, which calculates how often the model's predictions are correct. Then we have the precision score, which measures the proportion of positive predictions that are actually correct. Then we have the recall score, which measures the proportion of actual positives that are correctly identified. And finally, we have the F1 score, which is the harmonic mean of precision and recall. Next, we have import Seaborn as SNS, which imports Seaborn, a library for data visualization. It is built on top of Matplotlib and makes it easy to create beautiful and informative statistical graphics. Finally, we have the import Matplotlib pyplot as plot, which imports Matplotlib's pyplot module, which allows you to plot graphs and charts such as the confusion matrix that we will do. So now next step, which where we will be loading the data set. So I'll say load the data set and split it into training and testing sets. For that, I'll create a variable data equal to pd dot, I'll use pandas to read the CSV file, which is what we named as spam.csv. So we have that, and then I'll say X, which is our feature set. So we don't need the column spam in there. So I will say data.drop spam access equal to 1. So what I'm doing here is I am saying that drop the column named spam from the data set to create the feature matrix X. Now X will contain all the columns except the target column spam. This will be the data used to predict whether an email is spam or not. So where does that go into? Y? Y is the target variable, which is the spam column, which contains the binary labels 0 for not spam and 1 for spam. So the way you define it, you just say I want only one column which is spam. That's it. Now our next step will be splitting the data set into training and testing sets. So for that, I will call that train test split function, and inside that I will, so this splits the data set into training and testing sets, which will have, which needs arguments like X, which is our feature set. Next I need Y, which is our target, which is spam above that we have defined here. And then I need to tell it what is my test size. So out of all the data that I have, I want 20% of the data to be test, whereas 80% of the data to be used as training data. And then finally I have random underscore state equal to 42. Now this is setting a random seed ensures reproducibility. You'll get the same split every time you run this particular code. So that's why you need to set it to a particular random number, so which is 42 in this case. Now this will give me a bunch of variables, which is, it will give me the training data, testing data, and training targets and testing targets. So that will be x underscore train comma x underscore test comma y underscore train and y underscore test. That's the format that I'll get data out from this particular function. Next, we will be training the logistic regression model to classify emails as spam or not spam. So let me write that down. Train the logistic regression model to classify emails as spam or not spam. So how do I do that? So I'll say model variable equal to, which one am I using? Logistic regression. So I'll set that. Then I'll say model dot fit x underscore train. It takes that and it needs y underscore train, and y pred equal to model dot predict, and I'll pass x underscore test to it. So what happens here is the first line number 18, model equal to logistic regression. It initializes the logistic regression model. The model dot fit, it trains the logistic regression model using the training features, which is xtrain, and the training labels ytrain. Now, next step where we are making predictions. What we are saying is after the model has been trained, this line on line number 20, ypred equal to model predict x test. This line uses the model to predict the labels spam or not spam on the test set x test. The predicted labels are stored in the variable ypred. Now let's go and print the data. So this is optional, but I like to do it. Print x underscore test. So this will print my data out. Now move it up for our next steps. Our next step is to evaluating the model using the accuracy, confusion matrix, precision, recall, and F1 score that we have done. So for accuracy, or let me write a comment here, evaluate the model using accuracy, confusion matrix. I'll use precision, recall, and F1 score. So how do I do that? So I create a variable called as accuracy equal to, I'll say accuracy score, and pass it y underscore test and y underscore pred. So here what's happening is we are calculating the accuracy of the model, which is the percentage of correct predictions, both spam and not spam. So that's what it does here. Next I'll say precision equal to precision score, and it takes the same variable, so I can just copy this and paste it here. So this calculates precision, which is the proportion of emails predicted as spam that are actually spam, which is that is like true positives divided by true positives plus false positive. So next I need the recall score. So I'm going to say recall equal to recall score and pass the same things y test y pred. This calculates the recall, which is the proportion of actual spam emails that are correctly predicted, which if you go by function, it's true positives divide by true positives plus false negatives. Next I need f1 score. So I'll say f1 equal to f1 score and pass the same thing. So this one calculates the f1 score, which is the harmonic mean of precision and recall. It provides a single metric that balances both precision and recall. So this has its own things. Now next is I'll print all these out. So I'm going to say print f, and inside here first I'll print accuracy. So I'm going to copy this from here. Actually, let me just 1 2 3 4 precision, recall, and f1. You can also say accuracy, precision, recall, so we know what we are printing, and f1 score. So there you go. Next step is to visualizing the confusion matrix. So for that I will be using so let's say visualize the confusion matrix using Seaborn's heat map. And for that I'll create a variable cm equal to confusion matrix, and then inside that it takes the same parameters. So this generates the confusion matrix, a table that shows, it will show me 4 different sections. One is true positive, which is emails that were correctly predicted as spam. It will show me true negatives, which are emails that were correctly predicted as not spam. It will show me false positives, which in this case are emails that were incorrectly predicted as spam but were not spam. And finally, it will show me false negatives, which are emails that were incorrectly predicted as not spam but were actually spam. So to do that, I'll say sns dot heat map, and it needs 2 parameters. One is 3 parameters. One is cm anot equal to true, and then fmt equal to d. So here this line uses Seaborn to visualize the confusion matrix as heat map. Anot equal to true is what I'm saying is annotates the heat map with the actual values from the confusion matrix, and fmt equal to do where format equal to decimal is saying ensures that the values are shown as integers and not scientific notation. And then finally what I'll do is I'll give a title first before finally. I'll call it confusion matrix. This is the title on top of the plot, and finally I'll say plot show. So save it. Now I need to import some libraries like Seaborn and stuff, but the best way to do it is I'm going to open it and check if I'm in the right folder, and I can directly write python day4.py. It will give me some error, hopefully not, because depending on what libraries I have or don't have. So looks like I have all the libraries installed. Sometimes Seaborn is not there, so if you don't see it, you can pip install Seaborn, and or sometimes Scikit-Learn is not there, so you'll probably have to import those. So depending on which one you're missing, you can import those. And here I can see that first it got me all the data. You see here it picked up all the data from that data file, and it went through training the model, and it says the accuracy of the model is 0.91, which means 91% accurate. Precision score is 92%, recall is 87%, and F1 score is 89%. And then at the next line, it tried to plot our confusion matrix, which has the true positives, true negatives, false positives, and false negative in the four quadrants here. That is our confusion matrix displayed here. I hope you were able to follow along. If you have any questions, let me know and I'll get back to you. Thank you. Day 5, Human Activity Recognition using Smartphones Dataset with Random Forest. This project will classify human activities like walking, sitting, standing, etc. based on the sensor data from the smartphones. We will use the human activity recognition, which is HAR dataset from UCI, which contains data from accelerometers and gyroscopes in smartphones. The project will use random forest as the classifier. So let's start with the project. So first I need the data set. So I'm going to go again to Kaggle and look for the UCI data set of human activity recognition with smartphones. I'm going to download it from here. So let's open the data set here. I have two different ones. I'm just going to take the trained one because that's bigger, and I am just going to change that. I can merge both of them and create one, but I'll just use one of them as hard data set. I'm going to take this and move this to my online training, harddata.csv. Remember that. Go back here and create a new file. Call it day5.python. Now our first step is to import the required libraries. So I'm going to say import required libraries. And here, first one that I need is pandas. Now pandas is used for loading and manipulating the dataset. So I'm going to say import pandas as PD. Next, I need the train test split, which splits the dataset into training and test sets. So I am going to say from Scikit-Learn dot model selection import train test split. Next I need is the random forest classifier. Now that comes from Scikit-Learn ensemble. So I am going to say Scikit-Learn dot ensemble import. I want random forest classifier. This is the classifier that will be used for human activity recognition. And next I need my metrics. So I'm going to say Scikit-Learn dot metrics import. I'll do all of them. Confusion matrix, I'll need accuracy score, I need precision score. Since I've already done before, that's why it automatically populates and gives me better intelligence here, F1 score. So that's good. Next I need Seaborn, import Seaborn as SNS, and this one is used to create a heat map from the confusion matrix visualization. And then I need import matplotlib dot pyplot as plt, and this is for plotting the confusion matrix. So let's go ahead and first let's load the data set. So I'm going to say here I'm going to load the data set which I got from that URL df equal to. Now for future reference, if you want to use this, I am going to keep this URL in this document, so you have that data. And here I am going to say df equal to pd dot read underscore csv, and the file is har underscore data dot csv. So I have loaded my data set here. So this particular function, it loads the human activity recognition, which are HAR data set. The data set contains sensor data from accelerometer and gyroscope, and corresponding activity labels. We'll have like walking, sitting, standing, all that stuff inside this data set. Now let's go ahead and pre-process the data set. For that, I will first say pre-process the data set and for that I'll first drop the fields that I don't need, drop the column that I don't need, which is the activity on the axis equal to 1. So I have all my features in this particular. So it removes the activity column from the data set, leaving only the features which are the sensor readings. And then I need the y equal to df, and inside that I'll only have activity. So this will be the target variable, contains the activity labels, example walking, sitting, and standing. So if I want to go and check this out data set here, you'll see it has all these different data items here inside this, and my last column here is activity, and that's what is my target variable. So that's what I've set here. So perfect. Once this is done, I'm going to let's say split the data set into training and testing sets. Now that I can do using x underscore train, x underscore test, y underscore train, y underscore test, something similar that we did in yesterday's video. Test underscore split, and here I'll need x, y test size equal to 0.2, and my random underscore state equal to 42. Now if you have not seen yesterday's video, what this does is it makes sure it splits the data set into training and testing sets, and 80% of the data is used for training and 20% of the data is testing. The random state 42 ensures reproducibility of the split. And now next step will be to train the random forest, let's say to train the random forest classifier. And that I can do first. I'll create a model object, a model variable, which I will say random forest classifier, and to it I'll assign two different parameters. One is n estimators, which initializes, so this kind of initializes the random forest classifier with 100 trees. So n estimators will be the trees. I'm going to say 100, and then random state equal to 42. The random forest is an ensemble method that uses multiple decision trees for classification. That's why we have provided the 100 value to it. And then finally I'll fit this model by saying model dot fit, and then to this I'll give x underscore train and y underscore train. I'll give the features and the labels to it. So this trains the random forest model on the training data, x train and y train. Next thing is I have to make the predictions. So for that, so let's move it to the top, and then I will say y underscore pred equal to model dot predict, and inside that I'll pay x underscore test. So this will give me my predictions, and now let's evaluate the model using, so I'll say, let's also say here make predictions on the test set, and here I will say evaluate the model using accuracy. What all do we have? Precision, we have recall, and we have F1 score. So we'll say accuracy equal to accuracy score, and it knows what I need. Does it know y test and y pred? Perfect. I can do the same thing for precision equal to precision score, y test and y pred. Next I'll do for recall, I'll say recall equal to recall score, give it y test and y pred. Perfect. Next I need to do f1 equal to f1 score, and then inside that y test and y pred. Perfect. So that in place, I'll print it out. I can say print f accuracy is accuracy, and I can like last time we didn't do this, but I can multiply this by 100 and say point to f, so I have a better percentage. You can do this for all of them, but I'm just going to keep it for one, or I can just say this. So I have my accuracy, I have my precision, I have my what was the other thing, recall, and I have my f1 underscore score. This is f1, this is recall, this is precision. So I'm going to print all these out. So visualize the confusion matrix using Seaborn's heat map. CM equal to confusion matrix, and to that I'll pass that ytest and ypred. And then for the heat map, I'll say heat map, call the heat map function, pass the confusion matrix, say annotate equal to true. I want it to annotate. Next, I want to use integers only, so I'm going to say decimal values. And then for colors, this time I'll give a little bit different colors. I'll say blues as compared to last time. And plot dot title confusion matrix matrix, and then I'll say plot dot show. Let's see if it's right. Yep, looks everything is perfect in place. I'm going to go back to my command prompt and let's make sure we're in the right place. Yes, we are. And then say python day5.py. Run it. Looks like I have a typo here. Instead of random, I said random. So let's make sure that is fixed and fixed here. So let's go back, clear it out, run it again. And there you go. We have our predictions out here where it shows the confusion matrix over all the different values that we have depending on setting, standing. So all these different things are coded out here where we have six different elements here, as you can see, and it shows our confusion matrix. If you had any issues or problems while following along, let me know and I'll get back to you. Thank you.